Alright, so this chapter is all about radicals. Yesterday on your Carnegie, you started working on radicals, power functions, that sort of thing. That's what we're going to be working on today. Today we're going to look at inverses of power functions. We're going to look at the vertical line test, the horizontal line test, and we're going to try to graph inverses of functions. Okay? And again, like we normally do, we're going to use our Carnegie, but we're not going to use our Carnegie. Okay? We're just going to kind of follow it and use it, but we'll probably do our own thing. Alright? Alright, so a power function, if you'll remember, a power function is a function that has a power. What's the power on this one right here? This is just x. 1, right? Squared, cubed, to the 4th, to the 5th, to the 6th. Remember we did power functions a while ago, and we talked about the extrema in a power function, and maximums and minimums, and we talked about end behavior. How does an odd, this is page 664. How does an odd function end?
An odd number.
No. What is the end behavior of an odd function? Right, it's like this, or it's like this, right? What's the end behavior of an even function?
Like that.
Like this, or like this, right? This is a cereal bowl or an umbrella. I can't help it. I just gotta take them out. Alright, this is an odd function. It's got that non-matching end behavior. Okay? So on this particular function, they have graphed the width of a square versus the height of a square. If it's a square and its width versus height, it's the same. Yeah, it's a square. They're the same. So if I have width in the x place and height in the y place, it's going to be like 1, 1, 2, 2, 3, 3, right? Because it's a square. They're exactly the same. Now down here, they want us to reverse it. They want us to do height versus width. It's a square. Is it going to change? No, this one's not going to change. It's going to be 1, 1, 2, 2, 3, 3, and so on. So this is this graph going to look any different from that graph? No. Why not? Because it's a square. They're the same, right? If it was anything other than a square, would it be different? Yeah, it'd probably be different. It's a square. It's not going to change. Alright? So that's what that's going to look like. Is that a function?
No.
No. You said yes, and you said no.
It is.
Let's settle it.
Because
Clear the desk.
it is.
Why is it?
Because it passes the vertical line.
Exactly. Verify. Boom. Yeah, it passes the vertical line test. This is my vertical line. See that? It passes the vertical line test. There's nowhere that it touches it 2 times in the same place, so it passes the vertical line test. That makes it a function. That means that the x doesn't repeat. It doesn't match up with 2 different y values. Okay? So it is a function. I think we just answered a question on the next page. We did.
Can you draw one that's not a function in that real quick?
Something that's not a function? Not a function. See? Fails the vertical line test.
If it touches twice.
If it touches twice, it's not a function. Yeah. We just answered question C on the next page, by the way. It's a resulting graphic function. Explain your reasoning. It is. Brandon gave us our reasoning. It passed the vertical line test. It passed the vertical line test. Alright, now we're going to look at number 2, the quadratic function. Alright, so on 673, this is the graph that's in the top right corner. That's the one we're going to be looking at, side length and area. Side length and area right here. Okay, so has everyone found that? Alright, so transform the cutout so that it shows the area as the independent quantity on the horizontal axis and the side length as the dependent quantity. So, and then we have to sketch it. So what we're going to do is we're going to pick out some points from this instead of turning it and twisting it and making it match up. Let's just pick out some points and then we'll go from there. Okay, so if I'm looking at this, side length is in the x place and area is in the y place. So if I have a side length of 0, I obviously have an area of 0. If I have a side length of 1, what's that point right there? How far does it go up? 1. So, because 1 times 1 is 1, right? But if you'll notice, if I have a side length of -1, what's that point? How high does it go up at -1? 1, right? Because what's -1 times -1? 1. It's a positive 1. Yeah. What if I have a side length of 2? What's the area of my square? What's that point? How far does it go up when you go over 2? 4. What if I went over to -2? How high does it go up? Nope. Goes a positive 4. Okay, so that's on the original. Now what they want us to do is they want us to put the area first. And then the side length. So if the area was 0, what's the side length? If the area was 1, what's the side length? Ooh, hold up. I got 2 points there, right? It could have been 1, or it could have been -1, right? If the area was 4, what's that? 2, or it could have been -2. Yeah. So let's graph what we have here. So I've got 0, 0, 1, 1, and 1, -1, 2, 4, and 2, -4. I totally missed that point right there. Pretend I didn't. Is that one a function?
No.
No, it is not. Why is that not a function? So that definitely fails the vertical line test. Yeah. I should have asked more questions about that. I think that's fine. Yes. So, is that a function? No, it is not. How do you know? Because it fails the vertical line test. Anything more than 0, and we have 2 possible side lengths that could have given us that area, right? So, yeah. It's not a function. Okay. We are skipping all the way over to page 668. Woo! Did you see that? Alright, so we've got a cubic function. So find the cubic function there. It is right here. This one right here. Find your points that just like we just did. And I want you to graph the inverse on your own, okay? I want you to find some points, side length volume, and I want you to graph volume, side length. You picked out, everybody used 0, 0, right? What was that other one that you used?
6, 3.
6, 3. You went over 6 and up 3. And then, wasn't there a negative one too?
Yeah.
Like a negative 6, negative 3? Alright, I'm just going to use those 3 points. That's really funny. Okay, they want me to switch it. They want me to transform it so volume is the independent and side length is the dependent. This is still going to be 0, 0. What's going to happen to this one? It's going to be 3, 6, and this one's going to be... Oh, I wrote this something. Negative 3, negative 6. So I've got a point at 0, 0, 3, 6, negative 3, negative 6. There's that. Is that a function? Yeah, that's a function. It passes the vertical line test. So that one is a function. That one is a function. Alright, I'm going to erase this. I wonder why I just randomly does this erase this stuff. Alright, this is important. Okay? This right here, you're going to skip the end, but we're going to look at this. A function f is a set of all ordered pairs, x, y, or x, comma, f of x. Okay? The inverse of a function is the set of all the ordered pairs, yx, or f of x, comma, x, which is what we've been doing. If you want the inverse of the function, you invert it. You switch the x with the y. You don't change signs. You don't do any math. You just switch them. If it was 2, 1, it will be 1, 2. If it was 4, 7, it would be 7, 4. You just switch them. If x becomes the y, the y becomes the x. That's an inverse. Okay? Now, looking down here, look at x to the 4th on your page of graphs.
Big O U.
It would be what? It's a big OU. If I switch what's x and what's y,
It would be number
nope, that would be changing the sign. I want to switch what's x and what's y. It's going to go to the side. Right, it's going to be big OU going to the side. What page is the x to the 4th on? Or what page is this graph on?
Okay.
Okay. Not a function. How about the x to the 5th? What would it look like if I switched what's x and what's y?
It would be like, still
Yeah,
like
it's still, no, actually, because we don't change signs,
You just move over.
it's still going to look like that. It's going to spread out some more. Is that a function?
Yes.
X to the 6th. What's it going to look like?
To the side again.
To the side again. Yeah. Not a function. All right. What do you think about these even powers and their inverses? Can the inverse of an even power be a function? Why not? Why?
So is that middle one an odd function?
It's odd because it's x to the 5th. It's odd.
Ask the question one more time.
Why can't the inverse of an even function be a function. That's not a function. That's the inverse, and it's not a function. What do we know about the end behavior of an even? It's going to be what? Up, up, down, down, right? It matches. So if it's up, up, and it ends up going this way, what happens automatically? Fails the vertical line test, right? If it's down, down, it's going to end up going this way. What happens? Fails the vertical line test, right? But the inverse of an odd, like if an odd is like this, really tight, all it's going to do, the inverse is going to go like this. And if the inverse is like this, or if the function's like this, then its inverse goes like this. So it's going to pass the vertical line test, right? Okay. If we need to see the definition on the next page. If the inverse of the function is also a function, then it's called an invertible function. And its inverse is written like this with this little -1. But you don't say the -1. You say, if you wanted to say that, you would say the inverse of f of x. But that's a lot to say, so we just write it like that. So we use the vertical line test to determine whether or not the inverse of a power function was also a function. What test could you use on the original to see if its inverse would be a function? Yes, the horizontal line test. The horizontal line test. If it fails the horizontal line test, its inverse will not be a function. Once it gets turned on its side, it's gonna fail the vertical line test. And I think there's a definition of horizontal line test, right? Yes, right there. Horizontal line test is a visual method to determine whether a function has an inverse or not. Yeah, that's a good definition. You might want to underline that or highlight it or whatever it is that you do. All right, now I'm going to ask you to use your brain for a second. Oh, use your brain. I know. All right. If a graph passes the horizontal line test and the vertical line test, what can you say about the graph? If it passes the horizontal line test and the vertical line test, it's a function and its inverse is a function. Okay? If it passes both, it's a function and its inverse is a function. That's known as an invertible function. What if the graph passes the vertical line test but not the horizontal line test? Then what do you know? It's a function, but the inverse is not. Exactly. Right. Alright, and the last question we're going to do together. Given any point xy on a graph, what is that same point on the inverse? If I give you xy, what is it on the inverse? Yx. Exactly. Very good. When you get that one written, you get your skills practice out.